Hydrogen storage also. This is the nanochemistry enables the developments of the nanopores materials, which is having the metal organic frameworks. This is related to the carbon nanotubes, which is having the large surface area and optimize the pore structure. The catalyst of the energy conversion, which is having the size of it, the stage, which is increasing the efficiency of the energy conversion process, which is having higher catalyst activity. We are going to talk about it. The energy harvesting, of course, it will developing the nano generators, which is converting the mechanical or the thermal energy into this electrical using nanoscale parts. So the impact of it, which is allows the engineering materials, which is having the optimize the efficiency of this energy related application. As we saw with the real example, which is very important, the green catalysis, which is having here the photo of it that we are talking about, separation, how its selectivity, activity, the diffusion of it, and all of these parts. So the principle of this green chemistry, which will be more safer, more sustainable in this green catalysis synthesis here. To be more specific, let's talk about some points of it. I believe that Ms. Abtisam will be angry from me, but please forgive me. The renewable feedstocks will have some encouragement how to have the sustainable resources of it and how decrease the carbon footprint by having the non-toxic catalysts, which is it will be more safety even to deal with it. Also, we have the solvent-free aqueous conditions, which is having the green solvents. And this is, it will reduce the emission of the VOC, the volatile organic compounds, and lower the environmental impacts of it. Why? Because always we are having to focus about how we use this solvent, the solvent usage. The atom economy also, by having this green catalysis, it will maximize the efficiency of the reactions and minimize the waste generation, maximize the incorporation of the reactant at the final products. So this concept, it will be very important, especially for the economy part. Energy efficiency also, it will be important to more sustainable process. The catalyst recycling, it will be the development of it by having the enable of this recovery and reuse, and which is very, very important time. Not also we are focusing about how to emphasize this, how to generate it. No, we are focusing about how to do the recovery of it and the reuse of it. As much as we can repeat this process, as much we are success by helping our environment. Selectivity and specificity, which is more specific, that this kind of high selective and specific method and process, it will be having a kind of products which is having this minimizing of the waste of this process, which is very important. So I believe that the green catalysts, the strategy we have it, the researcher, industrial, so it will be more sustainable, more environmentally friendly chemical process. So this is very, very something promising in the future. I mentioned before for you the LCA, which is the life cycle assessment. In brief, we can say that this is the LCA, the life cycle assessment, which is talking about the resources, processing of the issue, how to do the manufacturing in the industrial field, distribution, the use, the end life of it. All of these points we are taking care of the LCA. So the LCA, it will be something very important to evaluate the impact of the product's process, like having the material sourcing and the synthesis, which is access the environmental impacts of this, by having the raw materials of the nanomaterials synthesis, including the extractions, and all of these processes will be in parts. The functionalization, which is related to the function of it, which is important part to have some kind of specific application. So this is, it will consider the energy and the resources, and also the nanotechnology application of it. It will also affect to the post of the concerning for the resource use and the energy consumption and the emission and the waste of this generation from it. Product life and the end life of it, it will account that we have the environmental impact for this part, how we use it and how we reuse it, and what will be happen at the end life of this part of material that we're using. Health and safety, the comparison between them, all of them will take care in the LCA. So here in the LCA, it will guide the design of these developments, and it will be very greener future, inshallah, in our nano field. I'm going just to conclude as much as I can. The challenges and the future direction, of course, we have some challenges actually regarding to the toxic material, the safety, which is having the nanomaterials, and it will be remain the major challenge, how to understand the toxicity, which is related to the toxic material, how the costs, how to adjust this economic part, how to do the standardization and the regulation, how to focus about the environmental impacts and compare between the regular material and our nano-green materials, how to provide this kind of nanomaterials with this kind of technology by having the issues like, for example, the careful consideration of the cost issue, the service, the function of this service. As I put for you here, we have different issue, how to minimize the service as much as we can in order to have the high efficiency at the same way. But the future direction, it will go to the other way, how to have multifunctional nanomaterials. We are using or designing the nanomaterials, which is combining the imaging, the therapeutic capabilities, and you have different like medicine, environmental monitoring. We use it for several issues at the same time. Smart nanomaterials, this is something very important, especially we are going to control the temperature, the pH, the lights, which is having the issue is very, very perfect impact actually. And also the biocompatible nanomaterial, which is having the safe and effective biomedical applications. And the nanoscale, as you can see here, this is the SME and the SEM, sorry, photo here. This is the real dimensions of it, how to have the large scale production. The environmental nanotechnology, the nanomaterials in the agriculture, the quantum computing, and also you couldn't believe that it will also having the space exploring here regarding to this photo. Now we can use it there, and the researcher there, they have some kind of nanomaterial. They are going to apply some research on it. So of course we have the challenge, but we will shape our developments of it to have the good way of applications by avoiding this kind of challenging. And we can conclude in briefly that the nanochemistry, of course, it will having this unique properties, and it will having the nanoscales, it will having novel applications and solution across the industrials and different way of our life, and the future mark of the innovation, sustainable, improve the quality of our life by taking care in the environment. And also it will having the helping how to develop the high performance nanomaterials properties, and how we have this achievement by medicine, energy, electronics. All of these fell together will be responsible, because this is the key of our global challenge to unlocking this transformative technology and go to the better of our words. Here we have some references, as I told you before, most of them, they are 2023, 2020, like this. And at the end, I just say you thanks for your listening. Ms. Ibtisam, you can go ahead now.
Thanks.
That's your voice, Mr. Ibtisam, صوت شوي.
Thanks you a lot, and you are finished your lecture in time. Thank you for that, and thank you for the
والله I'm running,
good
Mr.
information.
Ibtisam, I'm running, not jumping.
Yes, I see that.
بشوف الوقت وعبرقد أقول ابتسام الآن لا تنزعج.
Yes, thank you for that. Doctor, if you didn't mind, I want to ask you something. You know, the biggest thing of nano green chemistry, or we can say green nanochemistry, the development about the environment pollution. because we want to minimize the pollution.
طبعا.
Can you tell us about your experience, and upon your experience, which is the biggest thing that you find it, or biggest challenge you are find it in nano chemistry to develop the environment treatment?
طيب Hello, first of all, thank you for your question, Mr. Ibtisam. The idea that this is now a new field, especially for the green nanochemistry, and this is the recent 10 years, let's say, that this is a field. Of course, the challenges, they are very vast challenges, especially for the costs. Now, when you are doing your research, you need your resources, first of all, number one. Number two, after you finish this research, at the end, you are going to apply this in the real world, like let's say that for the industry. Now, how can you go to the industry and convince him that you have to use this kind of